G'day guys, we've got a question today which involves arithmetic and geometric sequences. Now what we've got here is we've got an arithmetic sequence which has a 50th term of 1853 and a 70th term of 1793. We're asked to find the 51st term and the first term. So what we're given here guys is we're just given terms and their positions, and we're asked to find in an arithmetic sequence the common difference as well as the first term. So what I'm going to do to start with, guys, in question 1, let's just write that down. Question 1, Q1, is I'm going to go about just recapping what the explicit way of defining an arithmetic sequence is, and that is we have a term, let's call it t to the n, is equal to the first term, which we're going to label a, plus n minus 1 times the common difference, d. So this is for an arithmetic progression or arithmetic sequence, guys. So let's just write that down, AP. Cool. So what we're going to do, guys, is we're going to enter in the information that we've got into this particular formula. So let's go about doing that. And what we have is we have the 50th term is 1853. So we're going to say 1853 is equal to a plus, now we have n, which is 50, minus 1 times d. Cool, now what we also have is we have the 70th term of 1793, so we have 1793 is equal to a plus 70 minus 1 d. So what I'm going to do now, guys, is I'm going to simplify both of these expressions, and then I'm going to put them both in terms of a. So let's go about doing that for the first one. So now that they're both equal to a, guys, what we're going to do is we're going to make these things equal to each other. And so what that's going to look like is we're going to have 1853 minus 49d equals 1793 minus 69d. So what I'm going to do now, guys, is I'm just going to change the 49 to the right, and I'm going to take the 1793 to the left. So I'm going to have 1853 minus 1793, which is equal to negative 69d plus 49d. Cool. So from here, guys, what we have is this is going to equal 60, and this here is going to equal negative 20d. So hopefully you guys are able to see that then d is going to equal negative 3. So what I can do with that piece of information, guys, is I can use that to solve part A of question 1. I can say, well, part A, we have the 51st term, or t to the 51, is equal to t to the 50 minus 3, which is equal to 1853 take 3, or 1850. Great, now on to part B. So what we're going to do here, guys, in part B, all I'm going to do is I'm going to substitute my constant difference into one of these formulas that I have here. So I'm going to say I'll just use this one here. A is going to be equal to 1793 minus 69 times d, which we know is negative 3. And what happens, guys, is once we've put that into our calculators, we get A is equal to 2000. So what we can do here is for part B, we have the first term, T1, is equal to 2000. Okay, so on to question 2, where we have a geometric sequence that has a 10th term of 98,415 and a 13th term of 2,657,205. We have to find the 14th term and the first term. Now we're going to use a similar sort of method of solving this as we did with the first question. To start with, let's just write down question 2. What we're going to do is we're going to write down the explicit version of the geometric formula. So we're going to write down t to the lowercase n is equal to a times r to the n take 1. Now, where a is the first term and r is the common ratio. So what we're going to do, guys, is we're going to enter in the information that we know. So we know that the 10th term is 98,415. So we're going to say 98,415 is equal to a times r to the power of 10 take 1. We're also going to enter in the information from the second part where we have this 2 million term, where we have 2,657,205 is equal to a times r to the power of 13 take 1. Now what we're going to do, guys, is on both of these formulas, we're going to make them both in terms of a. So let's just get some arrows going. So what I'm going to have is I'm going to have a is equal to 98,415 divided by r to the power of 9. And on this one, I have a is equal to 2,657,205 divided by r to the power of 12. Cool. Now what I'm going to do is I'm going to make these both equal to each other. Now what I'm going to do is I'm going to move the 98,415 down to the bottom over here. And I'm going to move the R12 up to the top over here. We can use the index law, guys. A to the n divided by a to the m is equal to a to the n subtract n. And we are also going to divide this number by this number. So what we're left with is r to the power of 12 take 9 is 3 is equal to, in this case, what do we have? We have 27. And then, once we've done that, we take the cube root of both sides. And we're going to get r is equal to 3. So, what we're going to do from here, guys, is we can solve the 14th term, because we know, let's just write down a, t14 is going to be equal to 3 times t13. And that's equal to 3 times 2,657,205, and that's equal to 7,971,615. And for part B of this question, what we're going to do is we're going to enter in our value that we've derived for R, our common ratio. We're going to stick this into there. Now, sorry for how messy this is becoming, guys. I'm going to just put the answer to this over here. So let's have B. The first term, or A, is going to equal 98,415 divided by 3 to the power of 9, which is equal to 5. Cool. So therefore T1 is equal to 5. So there are our two solutions, guys. We have A, or T14, is 7,971,615, and the first term is 5. What we did to solve this problem is we wrote down our standard geometric formula in explicit form. We then entered in the data that we knew, the actual values as well as their place in the sequence. And from there, we had two equations with two unknowns. We were able to solve them. Once we did that, guys, we then just used a little bit of common sense. We found the 13th term. We found the 14th term as a function of the 13th term, and then we used our common ratio to substitute into one of our equations to find the first term. So it's just about understanding what you're doing in each one of these, and then it becomes a bit of common sense on how to get from finding this common ratio to the final solution. So guys, I hope this video helped. If it did, please give it a thumbs up. If you have any troubles with this video, please leave them in the comments section below. Alternatively, if you have any other problems that involve sequences or any other kind of maths, please also leave them in the comments section below. I'm always looking for new video ideas. But guys, I'll say again, these sort of problems require practice. You can't just do one of them. You've got to do multiple versions of these kind of sequence problems so you can master them. So under test sort of pressure cooker situations, you're able to solve them accurately. So if the video helped, guys, definitely give it a like. Subscribe to my channel. I put out new videos all the time. But until next time, guys, just please keep enjoying your maths.